All right, so we're going to move on to this next problem. And what I'll say is first, I want you to try to set it up. I want you to draw the picture. I want you to list any variables they give you and put it on there. And I'll just remind y'all, they say fired horizontally. Try to remember on the last problem what that meant and see where you go. I'll pause the video and let you guys take a chance to work on this on your own. So I hope you pause the video. I'm going to go ahead and show you my setup for this. So bullet fired horizontally. So once again, we have this half parabola. So just like the last problem, what we're doing is we're starting from the vertex and we're just going down. Now, why I like starting horizontally is because, that means my V naught is completely horizontal, which means I have no vertical. My V naught Y is 0. So V naught is whatever my velocity is given, which is 230 meters per second. And my V naught X is equal to my V naught, which is 230 meters per second. So I actually have all the initial velocity terms. That's great. I love to see that. The other thing they give me in this problem, it travels 400 meters as measured along the ground. That's from here to there. They say is 400 meters. Now, when I'm drawing it out, I can see that looks like it's in the horizontal direction. So this must be my delta X. As far as your delta Y goes, they are asking you how high above the ground it is being fired from. So that basically sounds like the delta Y. So we're trying to find the delta Y. And I'm going to let you guys try to solve this problem. But I'll have the equations up here, and my suggestion, write down all these equations again. The more you do them, the more you'll kind of remember them. I give you guys all the equations, but it's good to just know what's kind of coming up ahead. I'll warn you now, this problem is not like a one-step solve. You will need to use at least 2 equations to solve this, and I'm going to let you guys try to work on this, and we'll see. So hopefully y'all pause the video to try to solve it on your own. I always feel like that's the best way to learn. I will show you the first step. So the first thing is I need to identify what equation from delta Y will I use. Well, when I look up here, I have this equation, but I'm missing some variables. I'm missing t, so I can't use this one to solve it yet. This equation does have delta Y. This one has delta Y, but I need Vy. And then this one needs Vy and t. So, I'm kind of stuck here. It's not looking like I have any way to solve it. I basically need to see if I can solve for Vy or t outside of this. Well, I only have 2 other equations to go to. There's equation 1. So equation 1, I have delta x is equal to V naught x t. Wait a minute. I have delta x and V naught x, so I can solve for t. I can solve for how long the bullet's in the air for. So delta x is equal to V naught xt. So delta x is 400, V naught x is 230 times t. You will end up getting t is, 400 divided by 230. I get I'll round it up, 1.74 seconds. All right, so that's my t. Now, what this does is it opens up equation 2. So equation 2 is delta y is equal to 1/2 gt squared plus v naught yt. Now, my delta y will be equal to 1/2 -10 times 1.74 squared. And I use -10 just to make the numbers easier. V naught yt. Now, I've gone through the step. I can make this 0 times 1.74, but I just want to emphasize this whole thing is just 0, right? If this is 0, I can just say 0. I can ignore it. It's gone. It's out of there. All right, delta y is going to be whatever this product is. What you'll see is we're going to get a negative number. We get negative 15.1 meters. And that's a great answer, delta y. Why is it negative? It's negative because I start higher and I go lower. So yes, I have negative 15.1, but they're asking how high above the ground. So that sounds like my answer will be 15.1 meters. All right. I'm going to I know this video is going to be pretty short. I'm going to stop it here and I'm going to give this last problem, which will be kind of an involved problem, I'm going to give it its own video. So I'm going to stop this one here and see you guys then.